Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain you another important model which is frequently given in the university exams in the recent times. So that is the two types of motions have been used in the displacement diagram. So regularly in the previous problems, we have discussed about the only one type of motion in the displacement diagram, and today's model is on two types of motion has been exhibited in the displacement diagram. So first type of motion in the outstroke and second type of motion in the return stroke. So that is today's model problem, and this is my 46th lecture regarding to the subject kinematics of machinery. So this is today's problem, which depends on two types of motions. So the first one is the simple harmonic motion, and second one is the uniform acceleration and retardation. So first of all, study the question and gather the information from the question. So construct the profile of a cam to suit the following specifications. Cam shift shaft diameter. So the diameter of the shaft is 40 mm. Next, least radius of the cam, that is radius of the cam is 25 mm. Next, diameter of the roller is 25 mm. So diameter they have given as 25 mm. And angle of lift is 120 degrees. So the angle of lift is to be 120 degrees. That is the outstroke angle. Next, angle of fall, that is 150 degrees. The angle of fall is 150 degrees, and lift of the faller is given as 40 mm. So the lift of the faller is 40 mm. That is called as stroke of the faller. Also, number of passes are 2 of equal interval between motions. So they have equal interval between the motions. And during the lift, the motion is simple harmonic motion. So lifting means that is the outstroke. So during the outstroke, the motion is said to be simple harmonic motion, and during the fall, that is the return stroke. the motion is uniform acceleration and retard deceleration, that is uniform acceleration and retardation. The speed of the camshaft is uniform, and the line of the stroke of the follower is offset. So we have to draw the offset camshaft, that is 12.5 mm from the center of the cam. So this is the given input for the question. So from this we have to draw the displacement diagram. So in this question, they have given the two types of motion. So in the displacement diagram, you have to divide the motion to two types. So during the lift, the motion is simple harmonic motion, and during the fall, the motion is uniform acceleration and deceleration. So first of all, you have to draw the displacement diagram with a height, that is the lift of the follower. We get it as 40 mm, that is the lift of the follower, and to the length we have to take the angle of the cam, that is one revolution of the cam, that is 360 degrees. We have to convert it into the length. So here I am taking it as 1 centimeter is equal to 10 degrees, thereby 36 centimeters of the, that is 360 degrees, can be converted as 36 centimeters. So we have to draw the rectangle by using the lift of the follower and the 360 degrees angle. So thereby we have drawn a rectangle and divide the rectangle into four number of equal parts. So four sections. In this first section is the lift, that is the outstroke. Second section is the dwell period. Which is having a dwell type motion, and third section is the retardation section, that is the return stroke. It is called as fall in the problem. And fourth one is the dwell again. So these four sections have to be taken. So in the first section, that is the outstroke, they have given the lift as 120 degrees. So during the 120 degrees, this is simple harmonic motion. So for the motion of simple harmonic motion, you need to draw the semicircle here. So draw the semicircle by using the height, that is 40 mm lift. So take the center in the 40 mm and draw the semicircle. So after drawing the semicircle, you have to divide the semicircle into 6 number of equal parts. So divide the semicircle into 6 equal parts. So then divide the semicircle into 6 equal parts and name the points as small a, b, c, d and e. Small a, b, c, d, e. Then divide the first section, that is 120 degrees, 120 degrees of the section. So we are taking it as 12 centimeters. That is scaling is 10 say 1 centimeter is equal to 10 degrees. Thereby divide the 120 degrees section into 6 number of equal parts. So divide these into 6 equal parts and project the lines from the divided points of the semicircle. So we have extracted the ABCD points and extend these points towards a perpendicular straight line towards the horizontal side, which is touching the vertical lines, which is divided from the outstroke section. So by intersecting these vertical lines with the horizontal line, we have obtained a point from each point. So first vertical line to the first horizontal line, we have obtained a point as B, and to the second vertical line to the second divided section of the semicircle, we obtained it as C. And next, the third vertical line, we have intersected the point as small c, and then we obtained a point as capital D. So similarly, in these positions, we have obtained the other points also, that is E and F. So by obtaining these points, draw the curve by using the freehand curve. By using freehand, we use it to draw this curve. So like this, we have to draw this curve joining from A to G, drawing from A to G between the points B, C, D, E, and F. Next one is the dual phase, that is the pause phase in the problem they have given test, and take the dual positions from G to H. From G to H, take the straight line which is of 45 degrees. That is 45 degrees means 4.5 centimeter. 4.5 centimeter. And then we are going to the third section. That is return stroke. Then, so in this fall section, that is in this return stroke section, you have to take the motion as uniform acceleration and deceleration. So in the question, they have given in that during the fall, the motion is uniform acceleration and deceleration. So in this uniform acceleration and deceleration, you does not have to draw the semicircle or extend that points. You have to simply divide the total section of the return stroke, that is fall into 6 number of equal parts, and from the center of the point, so this is the center line 3 dash, so 3 dash is the center line. So in this line, divide the points into 6 number of equal parts. So divide these points. So you obtain 6 points, that is 6 divided points in that. Then join the H point to these points, that is 1, 2, and first 3 points to the H position, and last 3 points to the P position. So by joining those, we have drawn the vertical lines from the divided points, that is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. From the points, 1 dash is touched at the first point, that is the J position, that is the J position, and 2 dash line is touched at the second one, that is K, and 3 dash is touched at L, 4 dash is touched at M position, and 5 dash is touched at the fifth position. That is, we have obtained these 5 points by using the uniform acceleration and deceleration position. Then we have to draw a freehand curve joining these points from H to P. So like this, you have to join these points from P to H. There we have obtained this line. And last, it is the dwell period, that is the first period. Simply draw the straight line over the length of AX. So likewise, you have to divide these sections, and we have two types of motions, that is the outstroke and the return stroke motions. So you have to notify these sections also, that is 120 degrees for the lift section, 45 degrees for the pause section, and 150 degrees for the fall section, and 45 degrees for the pause section. So then you have to draw the profile of the cam by using the displacement diagram. So they have given the roller follower. So you have to draw the roller first. So they have given the diameter of the roller as 25 mm. So the diameter of the roller is 25 mm, and the prime circle. This is the prime circle, and you have to draw the base circle first. So this base circle is fixed with the least radius of the cam, that is 25 mm. So the diameter of the cam is here 25. Sorry, radius is 25 mm, diameter is 50 mm. So identify the center and take the offset distance from the center of the position, that is 15 mm, which is given in the question. So the offset position is 12.5 mm from the center of the cam. So that is, they have taken 12.5 mm from the center of the camshaft. Then divide the first section, that is outstroke section, into 6 number of equal parts from the camshaft position, that is of the roller follower. So from this point you have to divide this section into 6 number of equal parts. So that is 120 degrees. So 120 degrees have been divided into 6 number of equal parts. Then after dividing the positions, extend these lines from the points and go to the displacement diagram now. Take the 1 and B as length, that is number 1 to capital B as length, and from the one position in the cam diagram, that is cam diameter, cut an arc in the extended line. So cut an arc in the extended line. So we obtain it as B. This is the B position. Next, from the similar one, take the 2C length. Take the 2C as length and 2 as center. Cut another line. So take the similar positions from the diagram and draw the positions. So take the similar positions and draw the section of this arc. So then join the points from A to G through a freehand curve. Take the points by using the freehand curve. Then take the length as OG and draw a curve from G to H by using a compass. Then draw the return stroke section also in a similar way of the outstroke section. So divide the return stroke of 150 degrees into 6 number of equal parts. Then extend those lines of the divided line. Then take the lengths from 1 dash to J, 2 dash to K, 3 dash to M, 4 dash to M, and 5 dash to N, and cut those arcs in the extended line. So that is these lines 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So you have to draw a roller, that is a circle for each point. For each divided point, you have to take that. So they have given the circle as 20 mm diameter. So the diameter of the roller is 25 mm. So in each and every point you have to draw the circle except these dual periods to the outstroke and the return stroke. Then we have the procedure of the drawing the cam profile. So first of all, we have to draw a prime circle with center O and radius. So here OA is the radius of the cam profile. Sorry, prime circle OA is the radius of the profile. So OA is taken as the least radius of the cam. So least radius of the cam is taken as 25 mm and radius of the follower, that is 25 by 2, that is 37.5. So you have to take it as 37.5 mm, and then you have to draw a circle with center O and radius equal to 20 mm to represent the camshaft. So to represent the camshaft, you have to take the radius equal to 20 mm and draw an offset circle with center O, which is radius equal to 12.5 mm. Next, join the OA. From OA, draw angular displacement of the cam. That is, draw angle AOS as 120 degrees. So this is the AOS position, which is of 120 degrees, which is the outstroke. And next, we have to take the dual period of 45 degrees and remaining return stroke 150 and the dual period 45. So there is equal number of passes because in the dual period it is of equal number of passes which has 45 degrees. Then we have to divide the angular displacement, that is angle AOS and TOP, into same number of equal even parts, that is same number of equal parts have been divided. Then from the points on the prime circle, draw tangents. So you have to divide the tangents to the prime circle positions. And then set off the 1B, 2C, 3D, etc. equal to the displacement positions in the displacement diagram. Then from those points, set off from one of equal divisions as measured from the displacement diagram. Join the points at ABC to P with a smooth curve. We get a pitch curve there, so that we get a pitch curve. Then now with ABC etc. as center, draw circles with radius equal to the radius of the follower from the each points of the outstroke and the return stroke. Draw the circles. Now join the bottoms of the circles with a smooth curve. So by this is the required profile of the cam. So that this is the required profile of the cam. So this is the way to draw the mixed motions. That is, in regular models, they will give the one motion to the cam profile, but in some proportions, they will give the mixed motions. That is, two types of motions has been given in the problem. Two types of motions have been rectified. So by these, I am going to end this class. Thank you.